Now next we are going to see about side effects. So in this paragraph, as you are aware, function as side effects when it have observable interaction with the outside world. There are situations our functions can become impure through. Our goal is to make our functions pure. Just to clarify, remember that side effect is not a necessary bad things. Sometimes they are useful. So in this paragraph what they are saying is when the function variable interact with some other variable or external variables, the variables are going to be affected in the situation. The function is called as impure function. This we already discussed. So actually this is the situation. In some situation you have to interact the function variable with some other variables. Always this side effects is not a bad things. In some situation we are in need to affect variable by some other variables. Next, another paragraph, modify variable outside a function. So now we'll see what will happen when we try to modify outside the function variable in inside the function. Here, when you try to modify the outside function variable inside the function will get side effect. At the same time, the function will become impure function. See, in the situation, the function doesn't take any arguments and it doesn't return any value, which is main important point. So here one example is given. Let y equal to 0, the variable of y declared 0. Here the function is defined with the variable of x. Inc is a function name, x is the variable. Here type annotation is given int, that is int is a integer. Here I try to modify the variable of y. Here y equal to y plus x. Return y. In this situation, let's see one example what is going to happen. In this example, we can see when modify outside the function variable in inside the function, what will happen. Here I declared variable y equal to 0. A function defined the keyword of def. Here inc is a function name, x is a parameter. Here by using the parameter x, I am trying to modify the variable of y equal to y plus x. Next I am calling the function increment. Let's see what going to happen. Here I run the program. Here it just displayed y, didn't return any values. So here in page number 5, that is what I explained in this algorithm. In the above example, the value of y gets changed inside the function definition, due to which the result will change each time. The side effect of inc function is it is changing the data of external variable y. And now next, from all of this examples and definitions, what we can understand about the main differences between pure and impure function. This is an important 3-mark question. Take page number 6. So that difference between pure function and impure function important 3-mark question, and also that algorithm also important 5-mark question. So you have to mark that both pure and impure function different, and also the GCD algorithm. Now we can see the difference between pure and impure function. Now we can see the difference between pure and impure function. First point is given, the return value of the pure functions only depends on its arguments passed. So wherein impure function, the return value of the impure functions does not only depend on its arguments passed. So here the result also depend on some external variable. Second point, if you can call the pure functions with the same set of arguments, you will see always get the same return values. In impure functions, if you call the impure function with the same set of arguments, you might get the different return values. And third point, they do not have any side effects. So here in impure function, they may have the side effects due to the external variable. Fourth point, they do not modify the arguments which are passed to them. So here in impure function, they may modify the arguments which are passed to them. So example for pure function, let square x return x into x. So here we not modify variable of x. For example, for impure function, random of and then date of. So each time of calling the function return the different types of values. Next, we can see the example. One example algorithm is given to find the greatest common divisor. So its example is based upon pure function. That is to determine the greatest common divisor GCD of two positive integer numbers. Here given the code, let is a keyword, REC is a recursive function. Already we know when using recursive function we have to use keyword REC. GCD is a function name, A and B are variables. Here checking the condition, if B not equal to 0, A mod B means modular means it will return remainder value. Here we calling the function recursively GCD function with the parameter of B and A mod B. If the condition is true, this function will be called. This recursive function will be called repeatedly. So when the condition becomes false, it will come to return statement, else part return A. Here output is given GCD of 1327. So output is 1. 1 is the greatest common divisor here. Clear? So this is what given in this paragraph. This example GCD is a function name recursively called till the variable b becomes 0. Here when the variable b becomes 0, it will comes to return part. So here if b is not equal to 0, it will call the recursive function. So remember, b and a mod b are two arguments passed to a and b of the GCD function. Under the topic of pure and impure function, it is almost covered 4 3-mark question and 2 5-mark question, which is very important topic in this lesson. So do you all understand, dear students?